All right, this video is going to be on standard 3 for your mastery exam. So first question here, write the equation of an ellipse in standard form given the following characteristics. All right, so let's see how quickly I can graph this. We've got 3, 5. So there's a focus. And then negative, whoops, haha. Let's try that again. Negative 1, 5 is the other focus. Semi-minor axis length, that's going to be B is equal to 4. All right, so center is going to be halfway between 3 and negative 1. So that would be, I think, 1, 5. We'll go with that. Okay, so then, right, C is going to be the distance from the center to a focus. That's going to be a C value of 2. All right, so skeleton. X minus 1 squared plus y minus 5 squared equals 1. If your two foci are horizontal to each other like this, you're more elongated horizontally. So that means your minor axis is going to run vertically. So that means the denominator underneath y is going to be 16. So then let's figure out my a squared value. So c squared is equal to a squared minus b squared. So that's going to be 4 is equal to a squared minus 16. Add 16 to both sides. I'm going to get a squared is equal to 20. I really don't care what a is equal to. So there is the equation in standard form for question number 1. All right, problem number 2. Write the equation of the parabola in general form. General form means, hold on, speak English. General form means I need to multiply it out. So let's see, we've got a focus at 4, 1 and a vertex at 0, 1. So that means this graph is opening up to the right. So skeleton-wise, we're going to be dealing with y squared minus 1 is equal to, all right, how far is the vertex from the focus? That is going to be a p-value of 4. So 4p is going to be 16, 16 times x, because there's the plus 1 there, won't matter for the vertex. And because this is the standard form. And if you were good with standard form, like that's it. But because I want general form, we're going to multiply this out. So y squared minus 2y plus 1 is equal to 16x. Y squared minus 16x minus 2y plus 1 is equal to 0. That is the general form. So remember, general form for circles and parabolas, you multiply it out, put it in put in alphabetical descending order. All right, I'm trying to do a speed run on this and get through the video, and of course I start talking too fast. Shocking. All right, problem number 3, find y such that that is on a circle with that center. So it's going to be x minus 4 squared plus y minus 4 squared, and then the radius of square root of 8 squared. All right, and I'm going to put in 2 for x. Okay, so that's going to be 2 minus 4 squared plus y minus 4 squared. Square root of 8 squared is just 8. So let's see what we've got here. 2 minus 4 is negative 2. Negative 2 squared is 4. So 4 plus y minus 4 squared is equal to 8. I'm going to subtract 4 from both sides. So y minus 4 squared is equal to 4 square root. Y minus 4 is equal to y. There we go. They're glitching less. Okay, so y minus 4 is equal to plus or minus 2, which means that y is equal to 4 plus or minus 2. So 4 plus 2 is 6, 4 minus 2 is 2, and that is what y is equal to. Either 6 or positive 2. All right, problem number 4. Determine the equation circle in standard form. So standard form is the one that we like because that's the one we don't have to like multiply it out. Okay, got it. Given the endpoints of the diameter, so we need to find a center. So I'm going to go halfway between 8 and 4 for my x. It's going to be 6. Halfway between -7 and 5. It's going to be -1. And here's the thing. I'll do a quick sketch here. So 8, -7 is down here. Let's see, 4, 5 is up here. And we're looking for that. So my center is going to be somewhere right here. Okay, that was at 6, -1. That point was 8, -7. So if I play connect the dots and I create a little triangle here to find that radius, my triangle vertically, I'm going from -7, -1. So that's going to be, what is that, 6 units. And then horizontally, I'm going from 6 to 8. That's 2 units. So 6 squared plus 2 squared is equal to, I'll call it r squared. So 36 plus 4 is equal to r squared, and I'm getting an r squared of 40, which the thing is, I don't really need to do more than that because when I write the equation, remember it's x minus h squared plus y minus k squared is equal to r squared, which, well, that's just 40, all right? Because I didn't actually ask you to tell me what the radius is. All right, so that's problems 1 through 4. Question number 5, these are going to be the questions on your sequences of series. I will give you these formulas on the actual final, kind of in the same way that you're seeing them right here. All right, how many terms are in the sequence? Well, let's start looking at the sequence. Let's see. This is, what, times by 2 each time? So this is a geometric. Yep. All right, so times by 2. How many terms are in the sequence? Well, we're going to use this formula. So the last term in the sequence, 128, is equal to the first term times r to the n minus 1. So if I divide both sides by 2, 2 to the n minus 1, what is that, 64? And then 2 to the n minus 1 is equal to 2. I'm going to grab a quick calculator here. Let's see. I think 64 is 2 to the 6th. I was right. Okay. So now I've got the same bases on both sides. I can say that n minus 1 is equal to 6, which makes n is equal to 7. And that's how many terms are in that sequence. Go ahead and move that calculator over. All right. Find the sum of the sequence. So let's say we've got here. This is going up by, what is that going up by? 5 each time? So -3 plus 5 is 2, 2 plus 5, yep. So this is an arithmetic sequence. The problem is I don't know how many terms are in this sequence. So I need to do that part first. So u sub n is equal to u sub 1 plus n minus 1 times d. I'm going to add 3 to both sides. So 75 is equal to n minus 1 times 5. I'm going to divide both sides by 5. That looks like I divided by 8. So let's try that again. Divide by 5. So n minus 1 is equal to 25, which makes 26 terms in the sequence. Did I do something wrong here? Oh, yeah. Haha. Brain fried. For anybody looking at me going, 75 divided by 5 isn't 25. Correct, 75 divided by 5 is 15. And then 15 plus 1 is 16. That makes a little bit more sense. All right. So then I'm looking for the 16th partial sum. So 16 over 2 times the first term, which is -3, plus the last term, which is 72. I grab my calculator back. I can. All right, so 16 over 2 times -3 plus 72. So the sum is 552, provided I can divide correctly. All right, problem number 7. A writer wrote 220 words on the first day. So U sub 1 is equal to 220 words. U sub 2 is equal to 230. So, okay, our D value is 10. How many total words did the writer write in 30 days? Okay, so we need to figure out how many words were written on day 30. So U sub 30 is equal to 220 plus 30 minus 1 times 10. You pop that calculator back out. So 220 plus 30, I don't know what I just wrote there. Hold on, delete. Okay, 30 minus 1 times 10. Okay, so U sub 30 is 510 words. And so then the 30th partial sum would be 30 over 2 times 220 words on the first day plus 510 words on the last day. So 30 divided by 2 times 220 plus 510. That's a lot of words. 10,950 words in 30 days. Okay. Problem number 8. There are 10 people in the first car of a passenger train, so U sub 1 is equal to 10. The train has a total of 22 cars, so N equals 22. The number of people in each car increases by a constant number, so there's some kind of a D value. U sub N is equal to 52. Okay, so we need to figure out... What do we need to figure out here? So I know... Oh, we need to figure out D. That's what we need to figure out. Okay. So 52 is equal to the first... So the last term is equal to the first term plus 22 minus 1 times D. So I'm going to subtract 10 from both sides. And so 52 minus 10 would be 42. 22 minus 1 would be 21D. So D is equal to 2. How many people are in the third car? So let's go ahead and do U sub 3 is equal to U sub 1 plus N minus 1 times D. So what would that be? 3 minus 14? We'll go with 14 there. Okay. So that's 1 through 8. Let's see. Question number 9, 10, 11, and 12 are all asking you to match. So let's talk about... all right. These are both ellipses. The difference is going to be whether we're elongated vertically or horizontally. So greater denominator here, that's going to be elongated more vertically like the y-axis. So that's going to be C. This one has the greater denominator underneath x, so it's more elongated horizontally. It's going to be D. All right, this is x squared. Whoops. This is x squared in a negative, which means we're going to be opening down. So that's going to be B. And this is y squared in a positive, which means we're opening to the right. So there's A. All right. Describe the method you use to solve each problem and why. All right, let's see what I can do here. Problem number 13, it's a quadratic, but unfortunately it is not a factorable quadratic. So how would I solve this? Quadratic formula. There's only one L in formula, and the reason is it is not factorable. Technically, you could possibly talk about completing the square here. I would highly not recommend that. I would definitely do quadratic formula. And then problem number 14 is an x to the fourth. As soon as I see x to the fourth, immediately I am thinking of u sub, and that will turn the problem into a quadratic, And this is a factorable quadratic. All right, so those are my reasonings why for that. And I believe that is the end of problem set for standard 3. As always, let me know if you have any questions or concerns, and I'll make another one for the next standard.